This video is to serve as a background to our algebra unit and really just the beginning of looking at expressions and equations and the different vocabulary that goes with this unit. So the first thing we want to do is talk about what is the difference between expression and an equation, because we'll study both throughout this unit. The simplest way to explain the difference is that an expression has no equal sign. Whereas an equation has an equal sign. And we can remember that because in the word equation, it looks like equal. Now, with that being said, that has some implications for each one. An equation, since it has an equal sign, it also then has a solution. So it can be solved. Whereas with an expression, since it doesn't have an equal sign, you're not saying that two things are equal to each other. So this has no solution. We can't solve an expression. We can't solve an expression, so really it can only be simplified. We don't get all the way down to like x equals a number, but we might be able to simplify it and make it look a little neater and a little more simple. The next thing we want to go over are some basic terms that you will hear us use a lot throughout this unit. The first is probably the most common, an unknown value in math that we represent by a letter. Hopefully you remember that that is a variable. Next, a number that stands by itself, meaning not being multiplied by a variable or anything like that. That is what's called a constant. So it's not changing because of a variable, it's staying the same by itself. The opposite of that, a number that is being multiplied by a variable, that is what we call a coefficient. Each group of variables or numbers that are separated by operators, operators meaning like plus, minus, those are what we call terms. Another word that means solve, we've seen this a couple times. I say it's the sophisticated way of saying solve, that is evaluate. Opposite operations, or operations that undo one another, are called inverse operations. We'll use that a lot in solving equations. A collection of numbers, variables, and operators, otherwise a collection of terms, we call that an expression. So like we just talked about on the previous page, an expression can't be solved, it doesn't have an equal sign, but we can simplify it. If we take two expressions and then set them equal to each other, it becomes an equation. And finally, terms that have the exact same variable or variables raised to the exact same power are what we call like terms. Hopefully most of these seem familiar, but keep watching to look at examples of labeling each of these within an expression or an equation. So now we want to focus on looking at an expression. Are we able to pick out specifically the number of terms, the coefficients, and the constants? So let's start with a simple one. If I look at 4x plus 3, I know that terms are separated by operators. So I see the operator of a plus. So I know that on each side of that we have terms. So I have two terms in this expression. 4x is considered one term because it's a group of variables or numbers. And then 3 is considered its own term. So within those terms, we have coefficients and we have constants. Looking at coefficient is a number that is being multiplied by a variable. So I know that when I see this 4x here and there's no symbol in between them, that means they're being multiplied. So 4 would be my coefficient. 3 is by itself and not changing, so 3 then would be my constant. In this next example, I have 0.2x minus y, and again I want to pick out the number of terms, the coefficients, and the constants. Looking, I still only see one operator, so I know that I have two terms. In this case, I have my 0.2x. And then looking at this second term here, I'm actually going to consider it as a negative y instead of just y by itself. And that way I know directly looking at these terms that it is a negative y, and then I'm not adding a positive or anything like that. That being said, for my coefficients, I'm going to continue that same thought. So the coefficient of x is going to be this 0.2 here. And then the coefficient for my y, remember if I don't have any sign, any number or sign at all in front of y, or if in this case I just have a negative sign in front of a variable, it's really like this invisible 1 in front. So when I go to write my coefficients, I'm going to list the coefficient of y as a negative 1. In this example, I actually don't have any constants because there are no numbers that are by themselves and not being multiplied by a variable. This last example has a good combination of a little bit of everything. Here, looking, it's a little bit longer of an expression this time. I have 3 terms, and that comes from 7, 9n, and just like we saw with that last example, I'm going to consider this last term as a negative 6mn. For coefficients then, I want to look for which ones of those terms have a variable in them. So looking at that 9n term, the coefficient of that would be 9. And looking at my last term there, the coefficient of that would be negative 6. The only constant I have that's not being multiplied by a variable and is by itself is that 7. So you're going to do some practice just like this, given an expression, picking out the number of terms, and then picking out coefficients versus constants. Don't forget when you do this to consider it as a negative if it has that minus in front of it. Good luck.